before we get officially started, are there any questions or anything somebody wants to bring up?
So are we going to go over the static? I what a static is?
Yes.
I okay. All right. Just kind of reading through the book here, and it's still a little confusing, but
Yeah, I hope to get to that toward the end of today's class. I was uh, I was pleased to see that everybody got 100% on the quiz. So that hopefully that was kind of like what uh, somebody said about Wagner's music. He said it wasn't as bad as it sounded. Um, so that's always heartening, and I think everybody more or less got to the finish line in the in Friday's assignment, and so applying the Oliver Twist methodology, as in, please, sir, may I have another? Um, so I've posted there's another computer assignment which is building on what you did on Friday, which is to kind of take that object and then uh, or take that class, excuse me, and uh, and write again just sort of a first cut at a whole deck of cards, but as an object, not as just as an array, in order to test what that single card class. We kind of wrote a little main method. The thing the thing to understand is that these at this point is that these main methods that we're writing are really just testing out what these classes are. The class, when you write a class like the single card or kind of like the light class that I did in class, those are kind of the key components. And an object-oriented program consists of instantiating objects and then having them send messages to each other. You've kind of heard me say that before, but hopefully, as you gain some experience in actually working with these, that'll kind of come into focus a little bit more. If that is still a little bit vague, that's okay. At this point, it's the implications of all that will hopefully become clearer as we start to work with these objects. And again, the one of the key differences between Java and JavaScript is the way that the objects are designed. In Java, the you write a class to create a template for what an object is going to be, and then you instantiate it using this new thing, which I believe JavaScript uses the same notation. The difference is that in JavaScript, because they don't have a concept of type really, or a strong concept of type, um, what they do instead, and to me this is an unfortunate decision, but they have you create this prototype. You say, okay, here's a prototype, and then I'll just kind of make kind of copies of this thing. And that when you're doing JavaScript, that should be your mindset. But then when you switch to Java, you should do a complete, you know, uh, put that aside. In other words, in Java, these templates are, a template is a better way in Java of conceiving of this. So we can stamp out as many of these as you want. And it's similar to the other, but the difference is that in defining a class, you're saying how every one of these objects is going to behave. And the the end results for the objects is the same either way. You know, if you write a JavaScript prototype, you describe what variables it has and what methods you can invoke on it. That's it. Just you do that by creating one of them. The difference is that in Java, when you write a class, there is no object. There is no object anywhere. Whereas in a prototype, when you write a prototype, there's an object there. Okay, so keep that difference clear, and then you know, you just have to do a context switch. If you are we doing JavaScript? Well, this is the way it works. If we're doing Java, we have classes, and that's the way that works. Okay, so now before I start talking at you, are there any questions? Again, as I was saying, I was very pleased to see everybody got 100% on the quiz. Everybody pretty much got to the finish line on the assignment. Again, there were a few little speed bumps, but they were all relatively minor. The thing to understand, and maybe I should have made this a little more clear, when you see a UML diagram, the thing about these UML diagrams is that they describe how the class is to be designed, and that you can consider that to be a design document, as it were, at least for the structure of a class. So I don't have any immediately here to show you, but picture in your mind one of these UML diagrams, and well, I'll tell you what, let me see if I can. Okay, in the assignment that I've asked you to finish by Wednesday, again, building on the other one, let me share the screen for that. Okay, so I give you another, here's another UML diagram. Okay, so this UML diagram is how your class needs to be written. So in this case, for this next assignment, I'm asking you to write a class called card deck. It will have two instance variables, one which is an array of single cards by this name, and one which is an object of class random, which is a Java class, and you know, so it's just another class. So when you write yours, this is the specification. So it needs to be that. And likewise, these are the methods in addition to the constructor. So the constructor sometimes is left out of this, but every object has a constructor, and we'll talk about what constructors are about at some point. But your class must have these methods with these return types and these names. That's the design. Okay, so there were a couple of places in the single card where somebody used different names or did it slightly differently, and that was something that is not. Sergio, okay. Maybe I was. Okay, I see somebody said that they didn't get 100. Okay, well, maybe I wasn't. I just did a scan of the top one. I thought I saw all hundreds. So that was. If you didn't, if you got less than 100, then make sure that you understand what was missed and why. I mean, again, anyway. Okay. All right, so today we are, come on, where are you here? Don't understand.
And Art, just one more question here. So the random generator I guess you already have the single card, so that's one class. Then the random generator will be in a different package.
The
Or Java, what do they call it?
Yeah, the random class is one that is already written for you. It's part of Java.
Yeah.
And,
Oh,
and in fact, if you look at the assignment on the web page, I actually, in fact, and if you do a pull on my my code, I kind of I walk you through a way to use random in the way that I'm asking you to do it here. So if you kind of again imitate what I did it's just a means of shuffling the deck. So again, think if you're if you're playing cards with actual cards, then before you play them, you shuffle them. So if you're doing a computer like thing, and like if you've played computer games going back to the early days, solitaire or things like um, all all pretty much every computer game these days has some kind of randomness going on. Um, and how do you do that? Well, you use these pseudo random number generators. That's a whole topic in itself. We'll maybe touch on it next quarter. But there are ways of generating these random or pseudo random numbers, and Java has several ways of doing that. Actually, every computer language has something built in for that. So the way to the suggested way is to say take an array and shuffle it. I kind of give an example of that just because that's that's just a way to do it. Now, for some reason, this is not showing my, oh, there it is. Okay. So today, and we're continuing sort of coverage of how Java does things, which in large part is a review of things that you've encountered in a previous language. In other words, JavaScript does most of this. And so when there's a control of flow, and that's usually here within a method. In procedural programming, this is something which is kind of front and center in everything. In object-oriented programming, all of that is in fact applicable, but it's applicable within a method. In other words, in Java, in an object-oriented language, all of the action takes place within a method. There's no such thing in Java of just having code that just sort of sits out somewhere. All execution in Java is within a method, within some method. Okay, and as you'll see in the class that I've asked you to write for the next assignment for this Wednesday, that there's going to be some iteration within the method that's going to involve the shuffling. There's going to be some iteration when you want to just print all the cards out on a single line, and as some of you, those of you who did the extra credit, as it were, in the single card, had to use some form of an if type of thing. There were several ways of doing it. Again, and those of you who did it successfully. So okay, so after this class, you should be able to write a conditional branch using if. The if is the conditional thing, and there are several forms of it. Unfortunately, different languages have slightly different syntax on this. So for example, when you get to the if else, for some reason, some languages decided it was too much work to write the SE. So instead of else, they would write elif. Who knew? Anyway, in Java, it's if, else, if, and we'll see what that is. There are three kinds of loops in Java. You've already encountered the for loop, but there are two forms of while loops, and we'll talk about that. And then when you're within these loops, there are ways of either breaking out of it using the break statement or the continue statement. Have you used those in JavaScript? The break and continue? Okay, so you're familiar with that. Yeah, again. Okay, so and then getting back to an earlier question, instance variables versus class variables, and instance methods versus class methods. So this class or static thing, class and static in this context are kind of the key words. In other words, static is what identifies a variable as a class variable, and it identifies a method as a static identifies a method as a class method. So the terminology is unfortunately a little confusing, but hopefully will be clear with usage. Okay, conditional branching. So there's if else, and then if else if. So and then the else if can continue indefinitely. And again, those of you who use this in that little extra credit thing, I mean, that was kind of an example of that. You know, so if it's a 1, say ace. If it's a 2, say deuce. If it's else, if it's an 11, say jack. Else, if it's etc. So that was kind of an exercise in that. Okay, so you're all familiar with that. We've seen the iteration. Now for iteration, these are the three ways of doing it. We've seen the for loop, and you're familiar with the for loop. And this is a way of describing it. So initialize, when I put things in like these little angle brackets, that means that's just sort of a generic thing that you substitute for. So the most common is like an int, you know, index equals 0. That's the most common. The test is when it stops. So when we were iterating over an array, the test was that index was less than the length of the array. And then the increment is how you increment it. And then everything, now keep in mind, let me keep sort of pounding on this idea of scope. So if you define the, if you remember, let me see, typically we would say int I equals 0. Okay, that was, this is and you can call it anything you want. But when you do this, the scope of this variable I is within the curly braces of the for statement. And once you come out of that, then this variable I that was defined in the initial part of the for loop doesn't exist. When a variable goes out of scope, it doesn't exist in that portion of the code. This is, and I don't know if you've encountered this, but all three of these are optional. You don't have to put anything in there. So this statement here, this is a legal way of doing it, and this will create an infinite loop. Okay, so in other words, you don't initialize anything, you don't test anything, you don't increment anything, and it'll just keep going on forever. Okay, now are you familiar with the while? Okay, yeah, so a while, and then here, there's a Boolean expression that you put there. What's a little unfortunate is that the scope of, you can't pull the same deal as here. In other words, if you try to define a variable inside here, it doesn't pass to the curly braces. So this Boolean expression or variable has to be defined outside the while loop. That to me is a bit of a wart, in my opinion. There's actually kind of there's a good reason for that, because this is just a single expression, and so if defining a variable within an expression is kind of flaky. So this expression has to be defined before you can even evaluate it the first time. Okay, so Now, are you familiar with the do while? Okay, so all right, so while is fairly straightforward. So you have a Boolean, and of course, if you want an infinite loop, you can simply say while true. Say true is a Boolean, which is always true. If I say while true, then this is going to be an infinite loop. Okay, why would you do that? Well, if you do that, then the program is going to get stuck here unless you have a break in there. So there are certain circumstances in which you actually want to do this. You say, well, I want to keep going until a particular condition is met. Now, stylistically, that's not so great. Stylistically, if there's something going on here that I want to continue doing this until some condition, or as long as some condition is met, then you should put that condition here. So even though this is legal syntactically, stylistically, it's something that you should avoid. Don't do that. Okay, so the idea is that you test it at the top of the block. So the block, this being the block. So you test first, and then so here's how to distinguish between this and the next one. If this expression turns out to be false, then you skip over the whole thing and move on. So this construct will execute 0 or more times. There are some circumstances in which, regardless, even if your condition is false, you still want to execute at least once. There are situations in which that is the case. So what Java provides is this way of kind of inverting it, and it's the do while. So what this does is you always execute this code in the curly braces, and then when you're finished, you do the test. And if this comes up false, then that means you just executed once and you're out. And as long as this stays true, you keep doing it. Okay, so that's now there are always ways of, how should I say, in a way that this is not strictly necessary. If you want to mimic that using the while construct, you just need to guarantee that the Boolean expression is going to be true at the very first time you evaluate it. Whereas here, this turns out to be much cleaner in certain circumstances. In situations where I want to guarantee that I execute this code at least once, and then see what happens. Okay, so again, while executes 0 or more times, do while executes 1 or more times. Okay, we've seen the our normal way of doing, let's see where, yeah, the for loop, you know, so far we've seen the for like this, but at one point they I don't know, there's something that I call the programmer virtue of laziness. And the virtue of laziness, basically, there are situations where doing less is more. And there's sometimes when it's just sort of silly. But what happened was they, at some point, if I want to iterate over an entire array, and I don't care about the index. In other words, if I've, for example, if I've already created my array of single cards and I just want to print them out. So instead of typing all this for I equals 0, blah, 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 I can use the for each, and it's in quotes because you say for Here's how you do it. You say for, and then you define the element, the type of the array, and you just give it a colon and then the array. And what this will do is this will iterate over the entire array. The difference is I don't have the access to the index. So if I'm just printing out the contents of an array, this is a little less typing, and it's also a little bit clearer. So here's where the programmer virtue of laziness is actually a good thing. Why? Because if I do this, if you see this construct, what I'm saying is I'm iterating over this. I don't care about the index, and I'm just going to go through all of them. Okay, and in the video that I posted showing how to shuffle an array using the random class, I show how to use this in a context of an array of integers, something like that. So you'll see an example of that if you look at the video. Okay, so you say that you've seen break and continue. So the difference is, well, a break immediately exits the block. So if I'm in any one of the loops, whether it's a for loop, a while loop, or a do while loop, if I hit break, if I say break, then it immediately bounces out of the block. Where's the block? How does the block get defined? By the curly braces. So in other words, if there's a break in here, then it goes immediately after the curly brace for that loop. Continue, though, is a situation where let's say I'm going through let's say I have an array of single cards, and I want to pick out the hearts. So and they've been shuffled, so I don't know where they are, but I need to look at every single card and then just sort of pick out what the hearts are. So there a continue, one way of doing it is I could use this for each. I could say for single card in the cards, if it's not a heart, continue, else do something. Or if it's a heart, then kind of save it over here, else continue. Something like that. So the difference is break will exit the block, whereas continue just jumps to the end of the block, but then continues. When I say otherwise exits block, well, the most common use of it, see, if I just say continue, then it's going to jump to the end and kind of it's going to skip over whatever code is kind of left there. So you almost never have it just sitting there naked, as it were. Okay.
All right, when you say the end of the block, I mean, are you talking about just that iteration through the loop?
Yes.
Okay.
Yeah. So so let's say I have a while loop. So here's a while loop, and then I have some condition. So here's a curly brace. I'm doing a bunch of stuff. Here's the end of my while loop. And if somewhere in here I say continue, what it does is it jumps over to here and then back up to the top. And then, of course, then it will either then execute another time through, or exit the so this when I say block, this whole thing, this is what I mean by block. So you can think of the contents of a curly brace as a block in this context, and that let's see, where does that terminology actually goes back to something called structured programming, which was something which was introduced at some point when in the early days of programming were like the Wild West. I mean, the things were, it was just like, it produces a lot of what was called spaghetti code. I don't know if you've heard that term, but basically it was just this, think of a plate of spaghetti. I mean, the code was just all mixed up and all mishmash together. The concept of blocks was then introduced. Again, this is pre-object-oriented programming, where instead of having spaghetti all over the place, you would execute your code in these structured blocks. And the curly braces came about as a way of identifying what those blocks are. So that in object-oriented programming, that's less of an issue, because now, again, your program consists of objects sending each other messages, but within each method, the same ideas are present. In other words, it is completely possible to write this huge method that has spaghetti code. Now, interestingly, Java did one thing. They were the first language to outlaw something called the goto, which we'll maybe talk about a little bit. Other than, well, since Java outlawed it, it's something that we can't really use and really shouldn't use. If you ask your grandparents about what programming was like in the early days, basically everything was just sort of one big file, and every line had a number. And one of the things you could do is you could say, go to line 52. That's what produced this spaghetti code, because the go to this line, go to that line, go to the other line, and things were just all mixed up. It turned out that the ability to just go to an arbitrary line turned out to be just a real bad thing. So over time, they kept saying, well, don't do that, don't do that. So Java, though, when it came out in the mid-90s, was the first program to actually literally prevent you from doing that. So the go-to statement was illegal. So that was one of the nice things. And anyway, but this terminology of block comes from this idea of the curly braces identifying that this portion of code is something. Okay, does that answer it? Now, are you familiar with the switch statement? I'm seeing some nods. Okay, so it's the same thing, and actually, if you think about it, the little extra credit thing on the single card would have most cleanly be handled with a switch statement. Okay, so how do you identify a switch statement? A switch statement is if you reach a point where I have a long list of else if statements, then that's probably a situation where you can move over to a switch. So the idea with a switch is you take some value and you go down the different cases. So you can have as many cases as you want. Now, in terms of stylistically, here's the thing. The default behavior is that things fall through. So for example, if I were to say case, let's say now this case, if value is an int, so if I were to say case 3 and immediately follow it with case 4, so if value is a 3, it will go here and then immediately go here for 4. This is one of the gotchas in this. So you should, in 99.9% of the time, always have a break after each case when you're writing this. The second stylistic thing is you should always have a default, even if there's nothing there. You don't have to have a default, but stylistically, you always should have a default. The way that I typically, usually the default should be an error. In other words, in this particular case, supposing value was an integer, and I wanted to make sure that it was a positive integer. That was the only legal thing. The problem is that this value, it has to be a variable. I can't do a switch on a number because a number is just a number. So if this needed to be a positive integer, and only these positive integers, or if it's something that's not one of these cases, then you should always have a default, which is an error. And you say, hey, you gave me, this is an illegal value. That's stylist. You don't have to, but stylistically, that's the way to do it. Okay, so you can't do a switch on everything. Here are the legal types. You can do an int. You can do a char. Again, we're not going to be using chars that much, except when we're going to have a little module later on where we where we kind of delve into strings, and so in that circumstance you might use a char. However, actually, since the book was printed, Java allows the use of a string, so you can do a switch on a string. And you can do a switch on something called an enum. We haven't talked about what an enum is, so you don't worry about what an enum is, but just know that there's going to be this thing called an enum, and those are the legal types that we can switch on. Okay, so now I want to talk about instance variables versus class variables. Okay, so now, everything we have been doing so far has been with instance variables. An instance variable, there is one per object. Okay, so the example is our single card. You know, so think of a single card. If the single card had an int value, let's just sort of look at that. So this was an instance variable, and each instance of the single card had its own value. And you know, think of how you tested that. I created 52 of them, and each one had some value between 1 and 13. Okay, so that's the instance. So an instance and object are synonyms. And here they must be declared private. And I say must, they're not, it's not required by Java, but you must declare it private to maintain encapsulation. Now, a class variable, we have not dealt with that yet, and given time, okay, if I have time, I'll try to show you that. If not, I'll do it first thing tomorrow. There is one class variable per class. In other words, if I were to define a class variable, there would just be one copy of it, not one per object, but one for the entire class. We define it by a static modifier. And they can be private or public. And so class variables, you're allowed to be public. When they're made public, we will typically make them final. And what final means is that you can't change its value. Now, instance versus class methods. So the thing is that there's, whether something is, we've been dealing, every method we've had so far, almost with one exception, has been an instance method. So get card, get suit, get value, toString. Those are all instance methods. And there's only one of those per class, because what is a method? A method is code that describes logic. So you don't have a new copy of that method for every object. There's only one of them. But using the static keyword defines a class method. So the difference in methods is what they can access. So an instance method can access both instance and class variables within the class. But a class method can only access class variables. Okay, so now that having said that, I'm not sure how much that lands, but let me try to I think this is, yeah, that's the last. Let me try to show you an example of how that works. Let's start up NetBeans. Is NetBeans working? Where are you? There we are. Oops, did I not? Sorry, just let me. I can see I actually need to commit that, but that's okay. So let's do that later. Okay, so so here's a single card class, and a couple things. One is I'll actually, I think, and one of you actually kind of did something like this. So here's a way to do this little to make the toString a little nicer, using a slightly different by making this a little cleaner. Again, it's not necessarily required. No, okay, so what I'm doing is I'm going to create a static, and I'll make it final. Just I don't know. Let's leave. Okay, so a private static array of strings that'll be the value strings, and what I can do is I'll just define those to be, say, ace, deuce, 3, 4, oops. Okay, what I'm doing is oops. Okay, so see the static keyword for my instance variables, there is none. Now remember, an instance method can access both instance variables and class variables or static variables. And so now, instead of this, all this, okay, I'll comment this out. Um,
Or what'd you do to, or what'd you do to highlight all that and comment it out? Did you have like
I'll tell you in just a second. Great question. Okay, I'll answer it after I just, you see what I did here? So now, see my value, and I gotta, okay, so remember my values go 1 through 13, so 0, I'd better blank out. So now, see, now my toString is just this. So that's this is the sort of clean, the way to make this thing cleanest. And I use that with a static string. So, so the thing is that every single card will have access to this, but there will only be one of these. Okay, so there are going to be 52 copies of this suit string when I make 52 single cards, and 52 copies of this value, but only one copy of this this array here. And so I can simply do that, and hopefully, if I've done it right, it should index out of bounds 13. I'd have to 2, 3, 6, 7, 8, 9, 10, Jack.
you have a plus sign after 7? And the comma is inside.
Oh, thank you. Yeah. Oops. Okay, so he's okay, so again, the difference is there's going to be one of these and one of these for every object, but only one of these for everything. Now, okay, so you were asking how I did this. So the way to it depends on whether you're on a Mac or a PC. So if I want to comment something, I can, for example, let's do this. I can highlight what I want to. I don't have to highlight the whole thing, but in this case, I just do command slash. If you're on a PC, it's control slash. And it's a toggle, so I'm just toggling it. Another little NetBeans trick. Okay. And you know, some of this is just a matter of taste. However, these static variables are situations where they're kind of what global variables should be. In other words, in Java, there's no such thing as a global variable because every variable has to be defined within a class. But if I'm in a situation where I want other, well, in this particular case, I don't want to create a new copy of this array for every single one. It would, if I didn't have the static, by the way, this would have exactly the same effect. I could run this and get exactly the same answer. However, that's for a couple things. One is that would not meet the design specification. That is, the design specification in the UML diagram for single card said that there would only be 2 instance variables and they would be called suit and value. So this would basically violate that if I made it an instance variable. But more to the point, I don't want a copy of this for every single one. Now, the other thing is that it is okay to make this public. But if I do, I should make it final. Why might I want to do that? Well, over here, so here in my main class, which is an entirely different class, in this method here, I can now access that from anywhere. And here's how I would do it. I would say single card dot, notice value names of 2. So you see that here outside of the class, because I've made it public, now if I run it, see, I can now see that. I mean, I'm going to comment that out, but that's just, okay, finally, going back to our hello world, or here, if you remember, the very first method that you encountered was the main method. Now let's look at how it's defined. Public, okay, so public means every class can see that. Now static, now it says static. So now you know what that means. What that means is that the main method is a static method. And the difference is, and we'll get into the difference is you call a static method by the name of the class dot the method. You call an instance method with a reference to the object dot the method. I'll say that again. You reference a static method by the name of the class dot the method. You call an instance method by a reference to the object dot the method. Okay, so that's it for today. And again, like I said, to take a look at the new assignment. Again, we're going to be working with the card class, and it's just another exercise in objects. But don't forget, if you remember last week, I kind of had this rant about encapsulation and arrays. So just be a little mindful of that when you're writing the new class.